Good afternoon, good morning, or good night to everyone around the world that is joining this webinar from IEA Bioenergy. It is the third workshop in a session of 3 about the application of biomass in industry. The first workshop was on the high temperature heating, the second one on specific industries that have a high demand for energy. And today it's about the application of biomass in the chemical industry. So we have a set of speakers this afternoon that will introduce you to the different topics and show to you what can happen. And after that, we will have a panel discussion with all the speakers to discuss the opportunities and also to see what we can do further. So welcome very much. IEA Bioenergy is a global network of a lot of different countries, and we work together on the development of bioenergy, but we also look at the development of bioenergy for wider applications like in the chemical industry. We have a specific task 42 on biorefineries, where we investigate all these possibilities. So you're welcome here to join this meeting. And also to give your input, we have for you specifically a button on the bottom. It's the Q&A button. You can use that to put there your questions. And we will record all these questions. And also after each presentation, we will try to select one question and give an answer on that. You can also use the chat to communicate, but we will not look for questions within the chat. There will also be a recording of this this session. So later on, people can watch it on the internet. But they will also see your questions and answers. So it will all be publicly recorded. So take care of that when you put up any remarks or questions. We will also use, let's say, the Slido instrument to evoke questions. And that will now first be introduced by Luc Pelkmans with the first question on Slido and also how to install Slido.
Okay, thank you, Kees. I will share my screen on the Slido. So also welcome from my side. My name is Luc Pelkmans. I'm technical coordinator of IEA Bioenergy. I'm also responsible for setting up this program for the workshop. I guess several of you have already followed one or two sessions that we had before, but just for the new people, just some instructions. So you can go to slido.com. You can open it in parallel to the Zoom system if you like on your computer, but you can also use your telephone, your smartphone. Just type slido.com and you will enter into the app. Also enter the access code, which is now R988, and then you can enter into the Slido, where we will have 3 polls for this session, and I will also present the central questions for the debate at the end. But now I want to open the first question. So I hope you have been able to access to the Slido, so it's not so difficult to get there. To give you some time and also for an introduction to this session, we have a general question. Well, would you be willing to pay more for bio-based products that have the same functionality as fossil-based products? So consider yourself as a consumer at home. If you go to a shop, if you have a choice between a fossil product or a bio-based product, how much would you like to pay more for that from your side? It's either nothing, either up to 10%, up to 20%, up to 50%, or even more than 50% extra. I see figures going up. We already have almost more than 50 participants at the moment, and there seems to be kind of a trend towards this 20% extra, which does seem nice, actually. I will leave this open during the next presentations, and then we'll come back to the final results there. But you can still fill in your Slido from your side. So I stop sharing from this side.
Thank you very much, Luc, for this introduction to the Slido question. So please continue to give your answer if you want to do that. So my name is Kees Kwant. I'm working for the Netherlands Ministry of Economic Affairs, for the Netherlands Enterprise Agency, and also the EXCO representative in the IEA Bioenergy. So I'm the co-lead of this, moderating this together with Ed de Jong from the company Avantium, and he will do the, let's say, panel discussion, and you will meet him later on. So it's now my my pleasure to introduce to you the first speaker. It is Stefan Ledoux from let's say INRAE, but also I had it on the screen, but the screen moved away. And so Stefan is a consultant at AllEnvy, an alliance of French research institutes, and he will introduce to us how, in his view, let's say, the bio-based economy can be introduced and how you do that in France. So the floor is yours.
Okay, thank you. Do you get my screen up? Okay, it was perfectly 5 minutes ago, but now up. It's okay on your side? Yes, it should be okay. So thank you for having me. Basically, what we have done at the Untitled Alliance, it's addressing a question that was asked by all the institution members of the Alliance. You can see the logo of them on the side of my screen. And what the question was, what is the difference with the chemistry from biomass? And what is needed from the academic science as a contribution in order to help that chemistry to emerge? The energy question was put on the side because there is another alliance who treats the energy question. It's called Ancre. So our focus was only on chemistry. And the question is, what will help the chemistry from biomass to emerge? What will be the limitation? And what could we expect from that chemistry and the impact it will have on the market? So we studied that on a very broad perspective. We didn't focus on a specific technology, but we wanted to see what will be the impact and the requirement for that new way to do chemistry to emerge. The first thing that we have noticed is biomass as limitation that you cannot find in fossil fuel, in fossil-based raw materials. First, the cost. The cost is usually much higher. I mean, it's in a scale, it's on the same level as the great commodity, the great petrochemical commodity cost around the same price as raw material from biomass. So you have to add the cost of transformation. So you will have a competitivity problem from the start. The availability is also an issue because biomass is something that we produce very commonly, but we don't do it in excess. Excess is not something that is very welcome in those sectors. If you have an excess of biomass in your production sector, your price will fall, and that's not something that the producer wish. We have a viability issue, the quality change from season to season. You cannot have everything you want at the same time. And the specificity, it's also a key issue because every biomass, in the same field of production, I mean, wood from the east of France is not the same from the south of France, and not the same species, not the same quality, not the same frequency. So everything is changing. And so what we conclude, it's very simple, biomass are not commodities. They may be traded as a commodities, but they are not. The secondary factor that we have identified as a limitation is sustainability and conflict of use. When you deal with biomass, you deal with very, very basic production of humanity. I mean, basically food or very basic resources. And the way you produce it will impact the way it can be considered as durable. And the way you collect the biomass, you will find yourself in competition with very, very basic needs of humanity, I mean food, and that will be a limitation that you have to address. And that's a key issue because in France, the main driving factor for the development of that economy is the balance of food production. That's why it's mainly concentrated in the northeast of France, which is historically a region that produces sugar and cereal. And that's a key issue for us because we start to have non-governmental organizations who address that transformation as a risk for the food supply. But I've addressed that point in my first slide. But so let's focus on that part. In the agricultural sector, surplus is not a good news; it's a bad news. It means if you preleve a vast quantity of biomass, you will unbalance the way that biomass is distributed and used. So you will unbalance, you will disturb the food sector, for example, and that's something would be a key issue. It means that if you have to develop that industry, and if you do chemistry, you will need a large amount of biomass, you have to be very careful because we have few experience in France about that we have a trend of surplus in the oleaginous production of vegetable oils, and by the time the industrial actors are able to collect biomass, the surplus are gone, and they have to pay a very high price for the raw materials, and they are unhappy. Another main difference between biomass and fossil fuel-based raw materials, biomass is a flow. It's renewable, but that's a flow. You have a limited quantity which is available. You can have that for eons if you are careful, but there is a limit on what you can get every year, every season. At the opposite, fossil fuel and fossil carbon, it's a stock. If you invest more money, you get more. If you want more biomass, I mean, there is a limitation of what the ecosystem can provide. And that's the first limitation. The second limitation that we have identified is there is a great synergy in the fossil carbon sector. I mean, Refinery produce basically liquid fuel. They have a byproducts called petrochemicals in which you produce plastics, and those petrochemicals generate leftover in which you make chemistry. In the opposite side, when you use biomass, usually it's a final use. I mean, what is used for food is consumed. You cannot do all of them at the same times. And most of the time, especially in the energy case, when you use biomass, nothing is left, which means there is no synergy. There is competition between the sector who needs the biomass. And that's a specific issue that we also have to address. And the chemical sector is very worried because he feels that he will not be the first to be served. It probably be the last. I mean, they don't want to initiate a competition with the food industry or with the energy industry. So they are very careful in what they can get. And also very, very strong point that we have to address is all the, let's say, there's a new set of performance associated with biobased chemistry. The environmental, it's a tricky word for more in English. The performance associated with the environment. And basically the whole balance was between technical performance and economical performance. Industrial actors have a good hand on how to deal with those two performances. The new balance, the one we targeted, it's a balance between technical and economical, but also the environment. And that's a very tricky balance. And so far, no one is very, let's say, confident on the way to balance all those performance. And that's something that we're still working on. It's just the evaluation of the impact of the production of biomass for chemistry is very tricky. I mean, we have many research groups who are working on it, but so far there is no, let's say, definitive method to assert that quality of production. Last slide, because I have very short time and I want to give more room for the question. We have identified 4 main goals to reach in order to be able to develop that bio-based chemistry. First, and that's something we are very cautious about because we are basically academic organization. We need a new organic chemistry. The organic chemistry that we have is very efficient, but it's fossil fuel based. I mean, we know to oxidize, we know to complexify the structure, because that's the way to get the chemicals. That's the way we get them from oil. I mean, if you get an organic chemistry class, I checked in all European countries, and that's always the same order: alkane, alkene, alkyne, then the alcohol, then the carboxylic acid. That's the way we produce them from fossil fuel. That's not the way we get it from bio-based sources. We get alcohol, we get complex structure, and that we need to be able to transform, to purify those structures were very complex. Of course, you can access very easily to complex molecule, to property, but the way we address it is very, very different. That we have to reimagine a new organic chemistry. And that's something which is more tricky than it seems. The second point is usable and targeted feedstock. You have to choose a feedstock that is available, sustainable, and in which you can have, let's say, a procurement that we guarantee for the existence of your industrial tool. I mean, there is no way an industrial will invest in a factory in which he's not sure that we will get starting materials for the next 20 or 25 years. Right now, that surplus model is not sustainable in an economical point of view, and that's a very tricky question because with the climate change, with the change of agricultural practice in Europe, nobody can guarantee that you will have enough feedstock for your process, and that's something very, very tricky. The third point, application market. I mean, in introduction, you ask to people how much they are willing to pay extra for bio-based chemicals. I see very, very unpleasant figure, 20%, 50%, maybe more. That's way too much. And industrial are not used to those premium price. That's the first point. The second spot is which application you will target. In France, we have a huge market for plastic bag. The one who fossil-based are forbidden. They are not allowed to be used. So we have bio-based one. But most of the people who contribute to the ban of plastic bags in supermarket, they don't want them to see them replaced by bio-based plastic. They want them to disappear. So is it a good application market? I don't know. But if you don't have the good application market, we'll invest a lot of money on something that will never exist. We have a market here for plastic cup for coffee on the coffee machine. And we have a new one in the office, and there is no more plastic cup. You put your own cup. So there is no need to...
1 minute left.
Okay. And only 1 point to go, so it's okay. Integration. And that's a key point. I mean, biomass is already produced into very well organized sector, food, paper. And if you want to have a bio-based chemistry, you have to find your place in that system. Energy can be part of the system. It has to be the last, because when energy is used, usually there's nothing left. You burn everything, and that's a good thing because it's a very easy valorization strategy, but that's an ultimate strategy. So chemistry has to find a space within those sectors without destroying their market and without consuming other supply. I'm basically done. Yes, I'm done. So I forgot to thank you for your attention on my slide, so thank you.
Okay, Stefan, thank you very much for your interesting presentation. And I think it's also an introduction about the careful introduction of, let's say, bio-based chemicals and the different issues that we have to tackle in order to reach that. I don't know if there are any Q&A questions now at this moment available. Because I have a question myself, because you are talking about careful, let's say, introduction. I think I agree it should be careful. On the other hand, we are also looking at very big challenges like climate change that actually require quite rapid action, where bio-based chemicals could play a role. So how do you see that?
It's a very, very delicate balance because if you have a competition with the food supplies, it's a tricky one. And we have in France a very tricky issue in the bio-based fuel sector, in which we are imported oil palm from Indonesia, because we have an industry who's running on canola oil, but that's only on season, and for most of the season, and for half of a year, we don't have supply for the factory. So the balance is good, but we have competition for sugar, we have competition for oil, and all those things are, I mean, I don't think there is a magic formula. It has to be very local. One point I forgot to mention, if you transform biomass for chemistry, you have to do it locally. There is a huge impact on transportation, because biomass is plenty of water, and if you transport water, you lose money, you lose energy. So that's a key point also. And that's also address the specificity of the biomass. You have to do with what you have. You have to do with what you can produce locally. The more advanced sector, in fact, is paper industry in the southwest of France, because they learn how to do with what they have. They put the factory in the middle of the forest. They have optimized the supply chain and the transformation chain.
Thank you very much. It's for answering. Actually, at this moment, more questions come in. So I would like to ask you if you could answer them through the Q&A session. Because of time, we now have to go on with the next speaker. Which is Cas Koenig from Groningen Seaport. So he will give his view, let's say, based on, as a CEO of Groningen Seaport, on how, let's say, this harbor can develop in a sustainable way, and what role renewables but also biomass can play in realizing that. So the floor is yours.
Thank you very much, Mr. Kamp. I will share my screen with you. And as a matter of fact, I hope you'll see it now. Can somebody confirm?
Yes.
All right. So I'm from the harbor of Groningen Seaport, and actually there are two harbors in the northern western part of our country. And I'm trying to skip to the next slide. Yep, there he is. We have a port in Delfzijl. That's one port. Mostly chemicals, circular economy, and bio-based chemicals. That is what we are aiming for. In total, 50% of the Dutch chemical industry is in this harbor. The other one is the Eemshaven. It's actually a relatively new harbor. It's from the 1970s, and there we are focusing on offshore wind. So we are installing wind farms from this harbor, as you can see on the picture. And we are on energy and data. For your information, 8,000 megawatts of energy is produced or is coming in this harbor, partly from gas-fired plants, coal-fired plants, but a lot of windmills, also solar panels. And we have two cables, one cable coming from Norway, actually with hydropower, and one cable coming in from Denmark with wind power. So a lot of energy, and therefore also the data centers are interested to come to this port and to put their data centers in. Yeah, the northern Netherlands actually quite up in the northern east part of the Netherlands. It's the hydrogen capital of Europe. Actually, we got a fee from, or a subsidy from Europe for taking care of the hydrogen valley of Europe. So 20 million subsidy. Very interesting for us. It's very well connected to the rest of Europe, and we're aiming for an energy transition. There's a student city. It's the city of Groningen, with 50,000 students on 200,000 people that are living there. So it's the youngest city of the Netherlands, actually. In order to achieve the climate, the Paris climate agreement, we had a system in the Netherlands where we wanted to reduce CO2 emissions up to 49%, and now it's 55% in the meantime. And they are even talking about 60% in Brussels. But we made a system in the Netherlands where the government asked the electricity sector, the agricultural sector, the mobility sector, the housing sector, and the industry to come up with plans how to reduce CO2 emissions. It's called a table structure of these five types of CO2 emitters. And actually the industry was divided in 5 locations, and one of the locations was our port area and a little bit bigger than that. And I was the chairman of this group of the industrial table, and we had to come up with plans how to reduce. And actually I invited 26 CEOs of the companies that you see in this picture, and these are the chemical industry, but also energy, as you can see, Engie, Nuon, RWE, the energy sector, but also agricultural firms like the milking industry, potato starch industry, and so on. They were also involved. Because in our opinion, we need each other in order to achieve the goals that were set in Paris. It was a very intensive situation where we had to come up with these ideas, and we had to compare 1990 with 2019 and with 2030. So what our expectations are. And as you can see, the CO2 emission in the bars and down under here, the CO2 emissions in our area already dropped significantly, and we expect them even to drop further. In the meantime, with a lot of new companies coming in our area, so the production in our area went up at the same moment. So if you look at the CO2 emission per ton product, you see a 54% of reduction on CO2 in our area. And with the plans that the companies, these 26 companies have, in order to achieve new reduction of CO2, we will go to 73% of reduction in 2030. So we are ahead of the Paris goals. To be honest with you, the Paris goals are not on CO2 per ton product, but they are based on real CO2 emissions, and therefore you will see it in the next slide. This is the line how the CO2 emissions went down in our area. We are now here, and these are the ways how we think that the CO2 emissions will drop further. So new systems, CCU, CCS, the carbon capture storage, carbon capture utilization, process innovation, and other sources. And there's the orange block here is a project that's not 100% confirmed yet. It's still in a test phase, so we're not 100% sure if this will be realized in 2030. So if you look at the absolute figure, we expect that our CO2 emissions will go down with 52%, and if this last project will be realized, then we will be down at 62%. So absolute figures. Now that's very interesting, and from all these ideas that we have how to reduce CO2 emissions, we came up with this very difficult figure. But to tell you, here are 33 projects. They are based on hydrogen, and hydrogen can be of a big influence on the CO2 emissions. And these are relatively small projects in all states, so it's production of hydrogen, it's transportation of hydrogen, and it's the utilization of hydrogen. And after seeing this, we made a consortium with the company Shell and the company Gas Union. And Gas Union is the gas transporter in the Netherlands, so they are having a very dense system of how to transport natural gas, and we came up with the idea of, it's called Nord H2, how to install and use hydrogen. I will show you this picture because we are up to here, Eemshaven Delfzijl. Here is our port where I'm responsible for, and we said we want to have till 2040, we want to have 10 gigawatt on windmills offshore. There's space available. and we want to build the electrolyzers in the Eemshaven. We have utilization of hydrogen in Delfzijl, and we have nearby, it's approximately 30 kilometers away, we have the possibility of storage underneath in the earth. It's storage in old salt mines that can be used for storage of hydrogen, large storage of hydrogen. So with the dense gas infrastructure that's already there in the Netherlands, they found out that it's possible to use the gas infrastructure for transportation of hydrogen. Of course, then you have to replace some compressors and valves, but it's good and easy, relatively easy to use it. And with this 10 gigawatt of offshore hydrogen production, or offshore wind production, and the production of hydrogen in our ports, we could supply Amsterdam, we could supply Rotterdam, and even Antwerp from the left side, pipeline construction, and on the east side, there's here another chemical cluster, and also in the southern part of the Netherlands, but also in the rural area, there's utilization of hydrogen. So it's a very ambitious project, and at the end of this year, the feasibility studies, there are a lot of feasibility studies for this project. I think at this very moment, 20 people are working on it. We will come up with the next phase. But in the meantime, we are realizing projects, and for example, in our Delfzijl port area, we have our own pit point where you can use hydrogen for your car or buses. So in our area now there are 2 hydrogen buses, but in next year there will be another 20 buses driving and riding on hydrogen, and they can tank in our port. It's hydrogen from the chemical industry. Just to give you an impression of this chemical cluster, this is the chemical cluster, and here you see a hydrogen backbone. This blue line, as you can see here, is already there. It's a pipeline to this pit point where buses can tank, of course outside of the chemical cluster. And we are now working on a backbone, this orange backbone here, where we can supply to other companies that are still using or are already using hydrogen, and next company that will come in the future that will also or produce hydrogen or are going to reuse hydrogen. On the picture on the right side, you see the king signing the pipeline that we as the Port Authority made. Our engineers found out a plastic pipeline where you can transport hydrogen instead of using steel pipes. And it was signed by our king, so it must be a very good one.
2 minutes left, 2 minutes left.
All right. In order to help our companies in our port area, we as a Port Authority made a lot of pipeline connections. So for hydrogen, steam, instrumental air, sealant, wastewater, in order to connect them. So we are the owner of these assets, but the material that's flowing through these pipelines are not ours. They are from different companies. Like for example, this one, it's a power plant based on biomass, a biomass power plant. It's making steam, and we are transporting in our pipelines the steam to the chemical industry to use it. There are several producers of steam in our port. But also a new development is the RWE coal-fired plant that's now switching from coal to biomass. It's a 1600 megawatt power plant, 2 times 800. Here we have a large area that we're going to make ready for new companies to come, and they are all bio-based. So, for example, Sky Energy is making bio-kerosene for the aircrafts, and Emerencia is going to make bio-based plastics. Jules is going to produce hydrogen. These are all coming in this area, as you can see it here. Sky Energy's, by the way, is part of KLM. And Emerencia, that's the one I already called, is they are going to make what's called PET plastic flasks we have now. It will be PEF, and that's then based made out of biomaterial. Actually, I hope I was within these 2 minutes, Mr. Quant. Thank you for your attention.
Thank you very much, Cas. You really did it within 2 minutes. This was,
Okay.
thank you very much. So it's time for questions. And so there is one question for the audience, from the audience, that from Jacob Kucheman, that's, let's say, asking to which extent can we do, let's say, introduction of bio-based chemistry decentralized and to which extent centralized. So, for example, if you think of the northern part of Groningen with all kinds of biological residues that are available, what can be done in a decentral way, and what would you like to do, let's say, in the central way?
Yeah. In my opinion, what we are aiming for is, of course, in a central way, not only because we want to sell or to rent the land that we have for newcomers, but I think that the plants that are now coming, the guys that we are going to come to your port area, they are doing it because they can use material from each other. They can use the hydrogen that's produced in our port facility. They can use steam for heating up things and so on. So we see that the business case from these companies is getting better because they are all centralized at the same very spot where they are together. So,
okay.
but of course, there will be also room for decentralized. Yeah.
So utilities are very important at such a central location. So steam, of course, is very much needed in the chemical industry. So the question is here, how can you store bio steam?
Yeah, biosteam is actually not to store. That's but as a matter of fact, in the steam pipeline system that we have 3 companies that are feeding in, and we have 7 consumers of this steam. So we are balancing the steam in the pipelines, depending on the production, of course, in the chemical industry, which who is using the material. Yeah.
Okay, well, thank you very much.
The storage on hydrogen is in the salt mines. That's very interesting.
Yeah. Thank you very much. It's a very challenging development and also very promising that things on such a large scale can happen with new technologies and also with, let's say, bio-based and hydrogen. So the next point, it's a Slido question. So I'll give the floor to Luc Bergmans.
Okay, thank you. I will share my screen again. So just showing you the results of the previous poll. So we had 82 people who entered, and the main thing coming out was that people would be willing to pay up to 20% more for bio-based products. 27% said up to 10% more. Maybe this is not a representation of the general public, but I think it's quite good to see that there is indeed some willingness to pay more. Let's go to the next poll. So the next question which we want to launch towards everybody of you, the whole audience, is what are the challenges of using bio-based resources in chemical industries? First, is it sustainable production of biomass? Is it the varying biomass qualities, the access to biomass, because there's some dispersed availability? Complexes becoming more, processes becoming more complex, resources being more expensive, or is it a problem of public acceptance? I think you can indicate a few, I think up to 3, that you think are the most important challenges for this. Seeing that people are entering, so again, going to slido.com with the access code of R988 if you haven't done already. I see there's quite some things already moving. We will see the results after 2 presentations.
Yes, thank you, Luc.
I will keep it open for the next 2 presentations.
Yeah. Please continue to give your answers. We'll move now to the next presentation by Michael Deutsch, who is the Vice President Biochemicals Business at UPM Germany. So he's leading the innovation-driven Bio4 industry. So the floor is for you, Michael. Welcome.
Welcome. I hope you can see my screen.
Yes, we can see your screen. Can you put it on full screen mode?
Do you see it now on full screen?
No, we see now two pictures next to each other.
All right. Sorry about that. Now you should see it, maybe.
You should stop the sharing.
Yes,
Sharing
this is
okay.
it. And now on the bottom, yes, completely okay.
All right. Sorry about this start. But thank you very much to give me the opportunity to present one example from a pulp and paper company moving now to bio-based chemicals. It's about UPM, this Finnish company, with a claim UPM Bio4 beyond fossils. I think everybody, and that's the driver from all of us, it's the climate crisis, and that's the biggest challenge of our time. I think everybody will agree. In the end, it's about reducing emissions, finding alternatives for fossil-based materials, fuels, and materials. UPM. I don't see the screen anymore, but I hope you can see the next page. Yes. The mega trends, I think, pretty much support the business of UPM and the strategy of UPM, providing sustainable materials to the society. We are doing this since 180 years, I would say. I mean, it's a very old traditional paper company, if you want. So the paper industry has been bioeconomy since the beginning, and in the last 30, 40 years, also using recycled paper. It's also a very good example of circular economy. Circular economy and bioeconomy is anyway, I would say, very similar and needs to go hand in hand. Just one sketch about UPM. It has been a paper company, 10 billion euro business. Nowadays, it's only 5 billion euro business for paper. The other 5 billion euros come from new businesses. We are a European company. I skipped that slide, but it's quite important that all of our products are based on sustainable managed forestry, wood from sustainably managed forests. We are using 27 million cubic meters of wood every year. And some parts, or most of the parts, is used for paper making nowadays. And again, paper making is paper usage is a good example for circular economy because it can be recycled quite many times. But, and Stefan mentioned this in the beginning, producing biomass always means how we use our land, right? And how for what we are using it for. So in the balancing, on the one hand, the needs for food production, for material production on the one hand, but then the loss of biodiversity, and to cut trees, for example, might also, or you might think of losing, or you set carbon free in the end. But if you do it sustainably, and if you create demand for forests, and you produce materials which are not, I mean, you don't use wood to create energy and to incinerate it, but you use it for materials, you store quite a lot of carbon, also the products. And if the products are recycled or used for long-lasting applications like construction, wood in construction, you really create a carbon sink also with the forest. And the more you demand wood from the forest, if you manage the forest sustainably, then the more carbon will be stored in the end. So, and then I a bit disagree with Stefan in this point. Stefan mentioned it is not, the target should not be to grow more biomass. I think in forest, it is the target to store more carbon in the forest, in the materials derived from the forest, because that is the carbon sink. Our company in our own forest each year store 4 million tons of carbon dioxide in our forest, despite the fact that we use the forest for wood production. So, and our conclusion is, if you see this is what hope looks like. You need to make sure that the forest is managed 100% sustainably, which means also that you take care for biodiversity, that you don't take wood from tropical rainforests, of course not, and these cannot be certified after these FSC or PFC standards, for example. And in our company, 100% of the wood is covered by the chain of custody. So we know from each of the logs we are buying from the forest, from where does it come. We also have own forests, and we plant every minute 100 trees. So that's our contribution also to CO2 storage. Guiding principles are, of course, selected sustainability development goals of the United Nations, where we can have a big impact. For example, water. I think we should be honest also that clean water is important, but if you convert biomass in any process, you need a lot of water. So management of water and cleaning the used water, I think that's very important. That's one example of this SDGs, but we have selected these SDGs where we have the most impact and we can contribute mostly to the development. We have also committed to the 1.5 degree value create to this target for the future, that our products should contribute to the global reduction of temperature increase. And we will measure and somehow compare and benchmark all of our developments if it fits and if it complies with this target. I would like to focus now the last minutes I have in my talk on our recent investment into a biochemicals biorefinery. It's quite a big investment. We will invest €500 million in Germany at the chemical site of Leuna to create an industry scale biorefinery and produce 220,000 tons of products off the base of wood. It's a developed process, or a couple of processes we have developed over the last decade, starting with either residues from sawmills, hardwood sawmills. This is used, or we use industrial wood, which means that's the wood if you do forestry and you want to make sure that some of the trees are becoming old. For sawmills becoming more than 100 years old, you need to take away younger trees and make some space and give some light to the others. The trees or the logs are then debarked, chipped. There's a wood to sugar process, sugar and lignin process. We convert the lignins into renewable functional fillers. I will come to this later, and convert the fibers to sugars. And furthermore, the sugars into glycols, different types of glycols. Leuna is a quite attractive location because you have the infrastructure of a chemical industry site, because the end of the process chain is typical chemical processes where you need also the infrastructure from the chemical industry. It's a big site where also a petrol refiner, the most modern petrol refinery in Europe, is located. There's a good connection to the train, railway grid and the street grid. And it's really in the center of Europe where you can supply your products to the customers, and you have access to the hardwood forests in Germany. And you need to keep in mind that in Germany you want to transform the forest from softwood forest into hardwood or mixed wood forest. But for the hardwood, there's hardly any industrial usage. So we create also value for the forest owners and help them to convert the forest from softwood to more climate stable and more healthy mixed wood and hardwood forests. MEG, as the main product, is the raw material for the PET bottles. PET bottles is or PET polyester products. The main application is the PET bottles, but also other packaging areas, as well as textiles. In Europe, I think packaging is more predominant. In Asia, textiles is more predominant. So we create raw material, make PET
One
bottles.
minute left.
Yes, make PET bottles and packaging and textiles even more sustainable. I mean, PET is the plastic which you can recycle endless, and it is already collected today. More than 90% of the bottles are collected in Germany, for example. For the losses and for the growth of such a bottle, we would provide them the bio-based renewable raw materials. And the other product is the functional fillers, which replaces carbon black and silicate in rubber applications. You know, it's up to 30–40% in rubber applications. The black color comes from carbon black, and our filler is a really very sustainable product which replaces the carbon black, which has a quite negative CO2 footprint. So I think that is really big contribution also to sustainability, is this fillers from lignin, which also shows you the uniqueness of our biorefinery, because we use all of the different components of wood, not only the cellulose, but also the lignin for producing products. It has been awarded already, this investment, by the World Bioeconomy Forum this year, and adds to the other awards UPM received for the sustainability strategy. With these words, I end my presentation, and thank you very much for your attention.
Thank you very much for this very interesting presentation, and also congratulations with all your achievements. There is time for one question, so I will take one of the many questions that you have got. You can see them in the Q&A. And the question is, there are of course also residues coming from all these trees, for example, the bark and so on. And so what are you doing with these residues? Are they also used in your biorefinery, or do they find other applications?
There are few residues, you're right. I mean, the most of the material we are using, beech has a very thin bark, so also the losses are quite low, and it's not lost because it will be converted to bioenergy.
Okay, so it's an energy source for your factory.
We sell it to partners who will incinerate it in a CHP.
Okay. Thank you very much for your presentation. We will continue now, also because of time, with the next presentation that will be given by Amit Goyal from the Southern Research. And Amit Goyal is Director of Sustainable Chemistry and Catalysis at this institute, and is also responsible for managing the programs. And he will present to us the case on the sugar-derived conversion to acrylonitrile. So the floor is yours, Amit.
Thanks, Kees, and good morning, everyone. Thanks for having me here. First, can you all see my screen?
Yes.
Okay.
Can you put it on full screen mode? Yes, that's it. Thank you.
Perfect. Thank you. So I'll be talking about a case study, if I can put it that way, for converting biomass into a chemical called acrylonitrile, and more specifically talking about its small-scale production with an application for carbon fiber. So this work has been funded by US Department of Energy. And as you can see, there are some other partners listed on the front slide who have contributed immensely to this work. So first, let's look at the bigger picture, what acrylonitrile is used for and where it comes from. If you look at the graph on the right-hand side of your screen, it shows acrylonitrile demand. And some of the major users of acrylonitrile are ABS plastics, which are used in things like Lego toys, in tires, acrylonitrile butadiene styrene, acrylamide, which is increasingly used for wastewater applications. And then of the last that I have listed here is carbon fiber, which is represented as a black small slither on the top of the bar charts. It's a small, it uses about 3 to 5% of all acrylonitrile that is produced, but it is the highest growing sector. And if we look at the graph which is presented on the left-hand side, it is a pie chart showing the uses of propylene. And propylene is the second largest hydrocarbon chemical produced either by naphtha cracking or by propane dehydrogenation. And as you can see, acrylonitrile is the third largest user of propylene. It's about 7 million metric ton that is produced per year around the world. I must mention that this is a class 4 chemical, and as a result, there are very few companies that produce this raw material, and there are only 26 plants around the world which all operate on propylene amoxidation, with an exception of one which uses propane as a raw material to make acrylonitrile. So now moving on to the next slide. I would really like to emphasize about the scale for which we are trying to develop this technology, and it's at a very small scale. Just to give you a comparison point, if you look at commercial acrylonitrile plants, they are typically produced between 100,000 metric tons all the way up to 250 to 300,000 metric tons. These are very large centralized plants servicing all kinds of application of acrylonitrile. With biomass, we think this is less feasible. We have had several presentations showing whether it is feasible to collect that amount of biomass, carry water, and various other reasons. So let's specifically look at a carbon fiber plant. A typical carbon fiber plant is very small. It produces, in terms of chemicals, it produces between 1,000 to 2,000 metric tons of carbon fiber, and which consumes a small quantity between 2 to 5,000 metric ton of acrylonitrile. So this serves as a great example of putting up a small, low capex, low biomass requirement plant, and it also eliminates, by making it a decentralized plant at the user site, transportation of hazardous class 4 chemical acrylonitrile from, let's say, for example, in US, from Gulf Coast all the way to where the carbon fiber plants are located. So safety is also an important aspect. Another thing that maybe is worth mentioning on this slide is majority of acrylonitrile users around the world are for small capacity. So the typical user will need between 5 to 20,000 metric ton. The only folks which make acrylic fibers or entire industry are larger user of acrylonitrile. So it can be actually produced, decentralized, and distributed for the end users. So let me give you a brief technology summary for what we are trying to do. So I mentioned about the commercial process is propylene amoxidation. And there is a other competing process that was developed a few years ago using glycerol from biodiesel industry to make acrylonitrile. And I'll talk more about it on following slides. What SR has been trying is to use second generation sugars, a mixture of C5 and C6 sugars to make some intermediates that are subsequently converted into acrylonitrile. The process uses a very small amount of non-renewable sources. And I think maybe Cass's presentation mentioned about smaller use of hydrogen, and I'll reflect on that. And we have also tried to make process a slightly less complex. So some of the catalytic steps have been combined into a single catalytic step, hopefully to reduce the complexity. And then there are two important attributes. One is the cost, so no premium, lower greenhouse gas reduction, the most important part for starting this project. And the last of all is, does this product meets the quality required for especially an application like carbon fiber? So just a brief slide on the process itself. We source C5 and C6 sugars from several commercial producers. And as you can imagine, depending on the type of hydrolysis process used to generate these sugars, they come with several impurities. So we take these sugars and first hydrocrack to make from sugar a mixture of glycols and glycerol. We separate them out. And then in the second step, which is dehydration, shown in a blue box in the center of the slide, we dehydrate this glycerol to hydroxyacetone and acrolein. These can be easily separated. And in the final step, this acrolein is oxidized using air and ammonia as co-reactants to make acrylonitrile. We ship this product around to some carbon fiber producers, and that's how we have a feedback loop to qualify this product as a usable high quality product. So just a couple of slides on the technology scale. We've been working on this for about 6 to 7 years. So phase 1 was catalyst development or process development, and phase 2 is a pilot scale process scale up. It's about 100 to 1,000 times, depending on the reaction you look at. And this is the current footprint of the plant, 3 reaction steps. This can produce about 1,000 kilograms of this class 4 chemical and other intermediates per year, or the plant can be operated at a kilogram per hour scale. It's a continuous decoupled plant. Here are some results from each of the reaction step I mentioned on my previous slide. So what is it's a very dense slide, but what is really plotted here is conversion of sugar or the conversion of intermediate and the selectivity of the desired product at the end of the step. And as you can
2 minutes left.
Most of these, thanks Keith, these catalysts are quite stable for the operation, and these have been tested with all the impurities present in the sugars to begin with. So this is the final quality of the product. It's about 99.2% pure. There is no production of hydrogen cyanide in the oxidation step, which is a disastrous, very hazardous byproduct in propylene oxidation. We actually verify this product for number of properties that are required for it to be converted into acrylonitrile. And what you see on this slide is the impact of impurities on the final products. And if it is green, it's great. And if it is red, there is some impact. So I leave this slide to mull over for later as you have access to it. And so the proof is in the pudding. So what you see on this slide is a control fiber made using petroleum sources and a biomass-based carbon fiber. And in terms of physical structures, these are identical. We have also made mechanical properties assessment on these, and actually biomass came out based on control fiber about 1% higher in mechanical properties. So one of the things that is typically difficult is when you start with biomass, you are paying higher for the raw material. And as you can see on this slide, in variable cost analysis, 52% of the cost is dependent on cost of sugar. And the sensitivity is plotted here to see for what level of sugar price one can afford to compete using this technology with petroleum-based technology. And also I would like to mention, since this is a small scale technology, I'm talking about a 5,000 metric ton plant, the capital investment are much smaller. It's between $15 to $20 million. That serves as a sort of an example for, for a first of kind plant, kind of a reduced risk environment to test it out. And an important thing to mention is the reduction in greenhouse gas emission. So these are apple-to-apple comparison from crude to acrylonitrile versus biomass to acrylonitrile. and there is approximately 95% reduction in greenhouse gas emissions. So this is where we stand with this technology. We are at this yellow dot. Several parties have shown interest, and we are looking for our first commercial investment. That's where we stand. Hope to have our first commercial plant in next 2 to 3 years. And I would like to thank the team members who have contributed to this work, and we'll be happy to take any of your questions. Thanks for your time.
Thank you very much for your interesting presentation, and also the way you develop this process and bring together all this knowledge to come to a very specific project that has, let's say, a much smaller carbon footprint than the fossil project. This leads also to I have one question here. So you mentioned that you could, per kilogram of product, you can have almost 6 kilogram of CO2 reduction. And did you investigate how the value of the CO2 reduction could help to commercial, let's say, viability of your process and your product?
So maybe I can highlight one point. If you think about carbon fiber is typically used as a product in automotive industry or wind blades. Carbon fiber industry is very empirical in nature and is less keen to change its own processes after they take raw material acrylonitrile in their plants. They do not want to make any changes to their own processes. Mm-hmm. To have a raw material with low CO2 footprint to begin with helps reduce not only their own carbon footprint for production of carbon fiber, but since carbon fiber is used for a long-term use in automotive or wind blades, which is again energy intensive or energy usage industries, the overall CO2 impact over a long use of life of this product is huge. It's actually maybe difficult to even capture for it not being used in terms of put a dollar number to it. But that is one of the keen interests of carbon fiber industry to adopt something like this.
Okay, thank you very much for this explanation. There might be more questions, so please have a look at the Q&A if you can answer additional questions. I think because we are now at a moment where, yes, we will have an additional poll question, isn't it, Luc?
Yes, that's true. Okay, so I will start my screen sharing again. And here you can see the results of the previous poll of what are the challenges of using bio-based resources. And you can select a few of those, and actually we see that there's quite a number which are relatively important. So it's not that some of them are really underestimated. So access to biomass is kind of on the top, but a little bit more than sustainable production of biomass. So both having to do with biomass, but also the process itself. So more complex processes and varying biomass qualities come out as very important. So I think it's interesting results. I will now go to the next poll. So the third. This will also feed into the Q&A that we will have later. What do you feel is needed most to realize bio-based markets? So do we need carbon tax on fossil resources, or do we need blending obligations for bio-based chemicals, or mandatory purchase requirements? Is it consumer awareness, purchase power which is needed, or brand owner pull? So we'll open this now. We see that people are entering in the slido.com. So if you aren't in there, go to slido.com with R988 access code, and we'll come back to that to the results after the next presentation. I'll stop sharing, but it keeps open for input.
Yeah, I think this will be very interesting information also for our panel discussion that we will have later on. So it is now my honor to present the next speaker. So this is Nelo Emerencia from the Biobased Industries Consortium. So hello, Nelo. That's some time ago that we met. So Nelo is at this moment Director Programming at the Biobased Industries. In the past, he was working in the Netherlands for the chemical industry. And this Biobased Industries Consortium is a public-private partnership and looking into bio-based applications. So Nelo, the floor is yours.
Thank you, Kees. I hope you can hear me. And
yes, we can hear you.
Okay, let me share my
We can
screen.
see you, but not
right.
yet your screen.
Let me see. Can you see my screen now?
Yes, there it is. And if you can put it in full screen mode, then the floor is yours.
Okay. I'll stop my video because our experience working in Brussels area here, that if there are many videos open, the connections start to blur and etc. So I'll knock it off and I'll start it again after the presentation. What I would like to do, Kees, in a couple of next 10 minutes or so, to give a highlight really of what it is that we intend to do, where we stand going from Horizon 2020 to Horizon Europe. And not going into too many details. I don't have the time to do it anyway. Plus, we are in the middle of a process with the Commission for the next step. Because as a starter, as you know, I hope many know, that we have this public-private partnership, a joint undertaking, if you will, with the Commission called the BBI, Biobased Industries Joint Undertaking in Horizon Europe, where the Commission brought in about $1 billion, which actually ended up to be less. And we set out to realize a leverage factor of 2.7. In other words, the initial plan was the Commission brings in the $1 billion and we bring in 2.7, and for a total of 3.7 billion program over 7 years, investing in bio-based operations in Europe. We're close to realizing that. I believe that we'll be heading towards a leverage factor over 2. Definitely. We don't expect to reach 2.7 exactly, but we're heading in that direction. We have 2 more. Well, last projects are running to 2024, and that's where the real count will have to be done. At this moment, we are in the process of discussing with the Commission the next public-private partnership, and there's a working title for it called Circular Biobased Europe. And for us and for the Commission, it's very important who we are and who we are representing as BIC, the Biobased Industries Consortium, and what it is that we are going to work, and or how do we work. And if you look at next slide here, I'm trying to depict in a visual and some words that we selected to cluster our strategic orientations in 4 pillars. The first one, strategic orientation 1, is to foster supply of sustainable biomass feedstock. One of the items that came forward in the last Slido poll there. It's very, very important. It's very challenging here and there. But here is where we focus on using existing feedstock as good as possible, and try and tap onto new biomass feedstock, residual streams, waste, whatever you want to call them, that today do not find added value applications. The second pillar is anything that has to do with processing. And here we're looking at introducing and using any applicable process, not only fermentation, but all sorts of processes to help us convert biomass, residual streams, etc., into value-added products. The third one is what we're looking into the products. We would like to use as much as possible of the existing functionalities in the molecules, if you will, in the biomass, rather than breaking them down all to the smallest building blocks and then start to functionalize them again. And last but not least, the fourth one is where we are looking into working with the market, with the consumers, with the brand owners, etc., to create the right environment, if you will, for acceptance and applications of bio-based products and solutions. Now, it is important for the Commission to know that we are willing and capable of proceeding along this route, but also it is very important for the Commission to know who is big and are we going to expand ourselves. And we want also to do that. And if I show you in the next slide here, these are the latest numbers of BIC, the Biobased Industries Consortium. We have over 240 industry members, large SMEs and clusters, including some brand owners, and market actors. And also we have over 200 what we call associate members. These are universities, RTOs, associations, etc. Numbers don't say that much. It's much more interesting if you see who we are representing. And in this slide, I'm showing that our members come from all these sectors: agriculture, food, feed, food processing, aquaculture and marine, chemicals, chemical industry, materials, forestry, pulp and paper, market actors, meaning brand owners, technology providers, and waste management and treatment. And this is expanding as we go on year by year. For example, the whole fishery sector was absent when we started, and now they're coming in with higher numbers because we see jointly the enormous opportunities to use waste streams from the fisheries industry. Now, if you look at where are our members are located across Europe, this is how we started, and you see this is the latest list picture that I show, dated in January. It hasn't changed that much, but it is changing as of this second half of this year, when we really start expand out into the central and eastern part of Europe. And this is, we accompany this to our program that we call the big strategic outreach program, really moving out into Central and Eastern Europe for more than one reason. There is enormous potential, plus there is enormous enthusiasm among the many actors that could be very valuable in the bio-based sector, but all they need is more cooperation among the disciplines, among the sectors themselves in their own countries, and also more linkage with the European networks. And this is where we, BIC, are assisting. And we do this via making country reports. CR in this window stands for country reports. We, BIC, what we do is, and we made ourselves the green mark, countries, Portugal, Romania, Poland, and the 3 Baltic states. We studied publicly available data on the countries and looking particularly into what sort of economic sectors are there in these countries and what is their strength and what are they doing. Plus, we continue what happens with residual streams in these countries and can we help? And we have a CSA project that delivered the findings just about a week or 2 ago. And that project covered the yellowish colored country that you see there. And in addition, they worked on some of these purple marked countries there. Our objective is to have these country reports of all these countries somewhere by mid next year ready. But we already started with a follow-up actions. Having a report is one thing, but now we want to, and we are moving out into these countries with assistance of our big members in either the countries, if we have them, or in surrounding countries, to help partners, to help actors in these countries themselves find each other and start erecting bio-based operations in these countries. It is absolutely not the intent of BIC to start moving biomass feedstock towards Western Europe or something like that. This will not help anyone. We're out to help establish bio-based operations in these countries, because that is what these reports have been showing, that there is enormous opportunities and enormous quantities of biomass feedstock for the industry available without taking that away from the food chain. So this, we are doing this, we demonstrated to the Commission that we are expanding ourselves across and helping to increase bio-based operations across Europe. And to do this, we also constructed, and we wrote down a vision looking way ahead to 2050. And the biggest move from the current system that we're working on is that we are now also extending out into the societies and the communities, involving citizens, because this is the only way that we must do to really have citizens also being active and motivated and support the bio-based industry. And we didn't write this only by ourselves, but we included and have the support of all these associations that I'm showing here, primary sectors, more into the products, including the chemical industry, so that we know for sure, and we can show the Commission that we are coordinating the broad sector itself. And having the vision, now we need a roadmap to go to realize these aspirations in the vision. And this is where the strategic innovation and research agenda comes in. We are now working on this abbreviated CIRA 2030, which is the roadmap towards these ambitions, with targets, with milestones set for 2030 to make sure that we're heading in the right direction. And I'm showing in the bottom ellipse here the 4 pillars that continue to be our core, and they are about the same as the 4 strategic orientations in Horizon 2020. The first one is on feedstock, but you see there we're using the word integrate. We ought to integrate the feedstock suppliers as strategic partners so that they also benefit from the value added in the value circles using their own feedstock. Also, the second one is accelerating innovative processing. It will create jobs in the end. We're out to integrate the demand for bio-based solutions by looking also at making products and solutions that really answer to societal needs. And last but not least, we're out to engage consumers and citizens to be part of this. So doing all this, we are bringing all this under this new public-private partnership now in a final stretch with the Commission. It's called Circular Biobased Europe. It's a continuation on the successes of the bio-based industries joint undertaking. And the key objectives I've highlighted there, you see these words, we're on to sustainability, we're on to contribute to climate neutrality, we're on to provide health and income, and by using using biomass in a circular way, as long as possible, keep the material in the processes and maintaining their value. And last but not least, we are out to improve the ties with the regions. And I will show you in a minute why a tool that we're using this.
It's 1 minute left.
I'm almost there. So we are out to establish a even stronger industry that will work on a quadruple helix basis. And to show you the tool that we have established to enable this closer relationship with the regions, we have just launched a month ago this platform for industry and regions where we bring together industry actors. We have over 100 already in the database with regions across Europe. We have over 50 to where they can find each other. There's the demand and supply of needs of biomass, of technologies, etc. And this starts to work already. And this is what I would like to leave it. Thank you.
Okay, thank you very much, Nelo, for this interesting presentation, and also where we can see how Europe is heading forward in the area of the bio-based economy and the bioeconomy, and the role industry plays there, but also how, let's say, that can be implemented in the regions. Let's see, are there any questions at this moment to Nelo? Because my question would be, well, what do you see as the strongest driver? Is it, let's say, the industries that want to increase the market, or is it the regions that are looking for, let's say, additional employment, additional industrial activity within their own region?
I think what really ties us across Europe is the drive towards sustainability. The drive towards reducing greenhouse gas emissions, the drive towards reducing the dependency that we have now on fossil-based material. It's that drive. And we also, in Europe, we depend a lot in crucial areas of imports. It's that drive that is common across Europe. Wherever we go, everybody is full about that. Now, the question is how to realize that.
Yeah.
And here is where industrial actors in northwestern part of Europe that started already earlier in using biomass to go in this direction have been able to motivate and stimulate actors in more Central Eastern European partners to do the same thing. And the Central Eastern European partners in this effort realize that they have a huge potential, which is not being used. So it's rather this drive towards sustainability that is pushing us in the same direction.
Okay, thank you very much for this explanation. This brings us to the end of, let's say, all the presentations. And so now it's the time for the panel discussion. So I hand over to Ed de Jong, who will take the lead on this. But we will start there with a Slido question that will be presented by Luc. And then after that, I give the floor to Ed de Jong.
Okay, thank you, Kees. Just coming back to the previous poll question that we have. So what's needed most to realize a bio-based market? And we clearly have one option which comes forward for practically everybody. So 83% of people that entered this poll have indicated that the carbon tax on fossil resources is very important. After that, you also have blending obligations, mandatory purchase requirements, and consumer awareness, but this one is really coming on top. Okay, I will close this one, and then I will show you the questions, the central questions that we will have for the panel discussions, which Ette de Jong will moderate. First central question is, what are the main challenges for chemical industries to take the bio-based route? We already had a poll on this, but if you like to, so the audience can type here what they also feel that should be mentioned here. A second central question is what's needed in terms of markets and policies to realize this, is also connected to a poll that we had. And a third one, if we have sufficient time, is your opinion on where, so in which biochemistry sectors, for which products or which chemicals does biomass make most sense? If you, for instance, compare it to other options like carbon capture and utilization products or hydrogen itself. Okay, these are the three central questions. They are open for your input in Slido. So you see it on the left here. I will close this window, but meanwhile you can enter your input, and I will shortly summarize your input also in the course of this discussion. And now I will leave it to Ed to moderate this Q&A.
Good afternoon. I hope everybody can hear me. Maybe can the host also allow my video to be used?
Ooh.
Okay, this is a very interesting picture I have. I will change my virtual background because this is a little bit too green, I would say. Yes, I was trying to see if I could really catch up with the technology, but apparently I was not successful yet.
That was a bit strange, Ed. I would suggest that also the other speakers put on their video, their cameras, so it's good to see them.
Hello, Michael. Hello, Amit. Hello, Nelo.
Hello.
Yeah, so I'd like to welcome to all the participants. A little bit of background from my side. I'm working at the company of Consortium, also quite heavily involved in bringing bio-based chemicals to the marketplace. And I'm also part of the IEA Bioenergy task on biorefineries, where I'm a co-chair. I would like to kick off this question and answer session. So we have this first question, what are the main challenges for the chemical industries to take the bio-based route? Yeah, I see at the moment Michael is largely depicted, so maybe also because you are a big chemical company and took recently the step to make a major investment in bio-based chemicals. What have you seen over the past couple of years before you came to the decision as the main challenges to take this step?
I think you should, thank you, Ed. I think you should ask really the chemical industry. I mean, we are coming from pulp and paper industry. We are converting since years, decades, every year, more than 25 million cubic meters of biomass. And also the chemical industry is not against biomass, right? I mean, they are converting nowadays, I think about 15% of biomass into their products. So whenever it makes sense from economic point of view, at least in the past, it has been only the cost point of view, then they use biomass as a feedstock. So they are not against it. I mean, they just want to earn money, right? And make profits, and as everybody of us. Of course, I mean, it is a different model or different processes needed if you convert liquids or gases. I mean, that has been one feedback from the chemical industry always, from the engineers, from the technical departments, that they are not used to handle this feedstock, which is first solid, which might vary in the quality over the year, and which is also very oxygen rich. So it's very different starting material from their viewpoint. They would need to use quite a lot of water, and the pulp and paper industry is used to it. We are used to handle solid feedstock and to cope with this changed qualities of the material. That might be one part. And then, of course, I mean, it's a very much cost-driven industry, of course. If the society is not ready, and I think they have not been ready in the past to maybe pay for CO2, for less CO2 in their products, maybe there was no reason also from an economic point of view to change to biomass. I think there's a technical and economic reason. At least that is my observation. And again, if there's money involved, I mean, 15% is already based on biomass. It's of course a lot of oleochemistry as well as starch-based chemistry, but it is already existing.
Yeah, I thank you, Michael, for your comments. Maybe also a little bit from my Avantium background. I think one point what you didn't mention yet, but what is certainly I think is important is the volatility of the feedstock prices, the oil prices in particular. What makes it rather tricky for investors to have a long-term outlook for what kind of price developments we see. I think another issue what many of us will face is that we are basically having to jump on a moving train. Yes, I mean you immediately are asked for very high quality products at very cost competitive prices at a very quite often higher production scale. What makes it quite challenging to produce a new route immediately at this scale. And I think at the moment, it's very, very difficult to find adequate compensation for that. And what from an other thing, what we see actually from an Avantium point of view also is sometimes even the requirements set by Europe, for example, if you're entering, for example, food packaging production, are even set higher than for the incumbent products. That the amount of impurities in the new product needs to be lower than in the incumbent product. But from evolving to a safer society is maybe logic, but it makes it even more difficult to produce a new product if you are even have to be performing better than the incumbent product. Can I also invite some of the other speakers to give some input on this first question?
Yes, the question of the environmental performance is also an issue because we start to see that some of those bio-based chemicals are not really doing better in the long term on terms of carbon emission. So we have to be very careful on that because it's a promise that we give to the public, and if we don't fulfill that promise with bio-based chemicals, we will have an issue. And so that's why we focus on very well targeted use, because it's not because it's bio-based that it's good for the environment. And we have to be careful because too often people say it's bio-based, it's okay. I mean, for the biofuel, for example, it's not that easy to assess that performance. So we have to be careful on that, because if we disappoint the people who are ready to pay more for bio-based, if they realize that it's not that good, that the improvement is not that good, we will face some disappointment, and that's risky.
Yes, thank you, Stefan. I mean, I completely agree with you. I mean, and we have seen that also in our internal evaluations. However, I want to make one remark in this respect. In many of the, say, life cycle assessment comparison, I mean, we are quite often have to compare, say, the fossil production of the past. Quite often there's relatively very clean sources, and then you compare that with a very non-optimized production of biomass. And I do think that we also, from the fossil side, really look much more forward-looking. And I mean, what kind of sources are going to be developed in the future? Let's tar oils or tar sands or deep sea dwelling. I mean, and look at the life cycle of those kind of sources, and don't compare that with, for example, Saudi Arabian light kind of crude. Because I think that is not fair, and that is not the choice we are going to make. I mean, we are looking to the future, and we are going to say, okay, what is now the most sustainable way to do that? And I think that there's certainly a challenge in the life cycle assessment to really compare apples with apples and not apples with pears or apples with stones. But certainly also we should not really oversell our products. I think quite often that has been done in the past. And maybe without being too critical, I have a question also to Amit. Is he still is here?
Yes, I am.
I mean, you make this 95% reduction claim for your carbon fiber, yes? But I mean, if I'm enough informed, then I think the major problem there is really converting the PAN to the carbon fiber. And for example, all the nitrous oxide that is produced during that step. So why not take a different route and avoid altogether the use of the nitrous compounds in your carbon fiber, and use, for example, lignin or something like that?
Sure. So, so I think first of all, let me make a correction. The 95% reduction in CO2 emissions are only till acrylonitrile, which is the raw material.
Exactly.
It does not encompass conversion of PAN to, so that is exactly same as it is today if you buy petroleum or this. It's just a drop-in chemical. So people have looked at what you just suggested. They've been using lignin for a long time. There has been effort in US Department of Energy, more particularly at Oak Ridge National Lab, for over last 10 or 15 years of making lignin-based carbon fibers. And they've made significant advancement in making carbon fibers, but they fall short of required mechanical properties needed for automotive applications. So that's one. That's only one example of an alternative source. People have looked at polyethylene glycol, which is non-nitrous. Mm-hmm. From the inputs that we have received and several workshops arranged by US DOE, industry has been a little bit reluctant to move to a new monomer. As I mentioned earlier in my presentation, a carbon fiber industry is more empirical in nature, developed over the last 30 or 40 years. It's a series of ovens that basically convert, and it's the raw material, the monomer acrylonitrile, which provides these unique multiple reactions during its oxidation chemistry, which results in high mechanical properties of the end product. So it's not easy to translate with other monomers as of today. There are multiple projects that I am aware of who are looking at other alternative sources also. So hopefully we will find a solution to that as well, someone.
Good luck, thank you. Does anybody else from the panel have some additional remarks on this first question on what the main challenges are for the chemical industry.
Yes, Ed, if I may, this is Nelo. And I agree, I believe it was Michael who said it, you know, the best to speak for itself is the chemical industry itself. But what I see from what we see from a big perspective is that the chemical industry is very well aware of the potential, but also the challenges to move more towards using sustainable feedstock. As you may know, they just started, Cefic just started or launched a group called Biochem Europe, which is very seriously bringing in many actors to look into ways to sustainably introduce more biomass in the feedstock. The objective so far still being, and it's being extended, to have 25% share of bio-based products in the market by 2030. And more of us are looking at even increasing that target to up to 30%. And there's one way we in BIC realize there's no way we can really accelerate the bio-based industry across Europe without the cooperation of the chemical industry. It's not going to work. And that's why we're very happy to see that the chemical industry is also on this route. And it's not now. The chemical industry has been working on using this for a long time, but now they are also looking to a way to speed it up. And it corresponds to what we're doing. And looking and listening to, I believe it was Stefan was talking about not overselling. This is true for anything. It's not only for the bio-based products. Anywhere, anytime, we must be sure that we do not oversell anything that we're making. In the programs of BIC and in the bio-based industries and now CBE, we're looking at making drop-ins, bio-based products that will outperform, and bio-based products that are breakthrough, that are easy or more easily to be made, or possibly to make them as compared to making them for fossil resources. And in all these three steps, the chemical industry is along our side. And it is true that we cannot and we will not put out outperforming, or what we claim to be outperforming bio-based products without the proof. And we're using LCAs and whatever other methods that we can use just to prove that these products are indeed calling for a better performance. And whether they will be able to seek and demand a premium or not, that is up to the market to turn it out. But all I can say is that the chemical industry is on the same route towards using more sustainable feedstock.
Thank you, Nelo. I think also in consideration of the time, I would like to continue with the second question. I will first read out the question loud, and then I will give one of the panel members the possibility to respond. What is needed in terms of markets and policy to realize markets for bio-based chemicals or products?
I think at Kaskoenig here from Groningen Seaports, we have a good example in our ports. For example, we have the biomethanol plant. As you probably know, it's a biomethanol plant that's making biomethanol and normal methanol made out of natural gas. But they can make biomethanol, but they also can make, for example, artificial methanol by using hydrogen, green hydrogen, and CO2. And actually, what is needed is for this is that these methanol can also be mentioned as being biomethanol, and so that they can get a higher price for that. So at the end, legislation is needed in order to get all these type of products given the right name, and therefore can be get the work that is needed for being applied.
Thank you, Cas. I think I can partly certainly agree with that point, that legislation is an important part of it. I certainly think that there is a difference when you're talking about unique molecules, so for example in UPM's case the lignin part, or if you really have a drop-in UPM's case, for example, the ethylene glycol, that the drivers are a bit different. Yes, I mean, in our perspective, I think certainly a premium from the consumer or the brand owner is quite limited. I think here the panel was, I would say, quite optimistic with 20%. I think quite a few of here on the panel would really be very pleased if they get 20% premium on a drop-in. And I think that is probably smaller. And certainly with a premium, I mean, the discussion about sustainability, etc., becomes much more important, I would say, because, I mean, a premium of a drop-in is mainly used in marketing. So you must be completely 100% sure that you can justify any discussion about that. And I think that is a kind of trick, because, I mean, some of us have the supply chains completely envisioned, but some of the others are maybe a bit more dependent from feedstock from abroad, etc., and not completely clear if all the sustainability aspects have been fulfilled along the value chain. Any more responses from the panel on this kind of needs from markets and policies to get this thing going?
If I may then add, this is Nelo.
Michael was also, so Nelo, after you, Michael will go. Go ahead, Nelo.
I'll try to be short. I think as usual, industry doesn't like regulations. You know, we want as little as possible of that stuff. But what we do need is stability. And what we do need in terms of this bio-based, this emerging bio-based industry, is the public authorities to help de-risk investments in this new industry, but also to get rid of legislations that today hinder the movements of biomass feedstocks across Europe and even within Europe. For example, the most easy example is waste. You have so many legislation about waste in Europe, it makes it almost impossible, even within one country here and there, to move whatever is called waste from one location to another. And we're not looking for moving waste, you know, across Europe, but even from within one country, moving from A to B, even a couple of kilometers. If you cross the boundary of a particular region, you cannot. So it's these kind of things that we are looking for to help this bio-based industry get really.
Yeah, one comment from my side. I don't like the term bio-premium because, I mean, it's not the same product, right? I mean, it's the same chemical functionality, yes, so you can call it a drop-in, but to the overall performance today of a product, I mean, the overall performance include also the CO2 footprint, for example, and the damage it provides to the environment. And then the question is, okay, what is the price people are willing to pay for less CO2? There's a lot of big companies who have a corporate target, and of course, it's always, if you talk to headquarters of these companies, they are really open to discuss this. I mean, they have a corporate target to reduce CO2 footprint, and if you offer a solution for that or contribution to that, then you can discuss also what are they willing to pay. I mean, that's one part of it. But I agree, if you just call it bio-premium, there might be no, or definitely less than 20% of it. And do we need support from legislation? Maybe yes. I mean, it was also the poll, in the Slido poll, that there need to be a price for CO2. I mean, if you want to reduce CO2, it needs to cost something. Is it a price or emission trading system? I think emission trading system has been shown in that segments which was applied, at least now when CO2 price is 25 euros or so, it showed some impact and some steering of the emissions and some reduction of the emissions. So I think that would be very helpful. But again, we don't sell the same product. Even if we call it monoethylene glycol, MEG, it's a different product, because if you look at the CO2 footprint, it's quite different to the existing ones.
Yeah, I think I can agree with you.
Yes, of course. I think we're sitting in the same boat.
Yeah. Amit, Stefan, anything to add to this?
Not much. I think it is, we talked a lot about bio-premium. One thing that helps, at least in certain biochemical segments, is consumer awareness or brand value that helps derive at least adoption, if not bio-premium, at early stages, and hopefully at smaller scales, to de-risk some of these investments and have first-of-kind adoption or demonstration. But yeah, in long run, for drop-in, the term bio-premium does not last for a long time unless it's taken with the perspective of long corporate goals of a CO2 reduction included as the sustainability index. So from our experience, it's a hard sell just with bio-premium to the industry.
Amit, I have also a question to you, what you might not be able to answer, but I mean, we all know that we have some elections going on in the US in the upcoming weeks. I think what I've heard up to now, I mean, in general terms, global warming has been a little bit addressed, but it is not really, in my perspective, a major kind of discussion point at the moment. But would you, how would you consider the results of the election in relation to, say, the development of the bio-based economy in the US?
So, as you initially mentioned, it's hard to answer this question. But I think even with the in the last 6 years, no matter what we hear in headlines, the bio-based industry or the R&D that supports bio-based industry, since it's a very young industry still, has not taken a huge hit. The programs that were initiated, let's say about 8 or 10 years ago, they have somehow maintained the momentum and continued. Certainly, I think as the election results come out, there might be a change in momentum depending on the outcome. But global warming is, with this coronavirus pandemic, has really taken a back seat in the discussions. And you might have already noticed that there are lesser discussions as well. So it's hard to read the minds. So I would leave it for the future to answer this question rather than being more predictive.
Okay, maybe we come back to that in a couple of months or a couple of years. Maybe also then a question to the European part of this panel. I mean, we have also, of course, in Europe quite heavily COVID. At the same time, we have the Commission who wants to have the Green Deal. How important is the Green Deal for bringing the bio-based economy further?
If I may, there is two sides of the Green Deal that needs to be considered. The side who concerns the production of biomass. I mean, if we follow the track which is online, the production might be reduced by the Green Deal. So we may see an increase in price of biomass. And on the other side, the market for using global product maybe receive some incentive. So it's a difficult task to predict that, because if you look at the agriculture part of the deal, being at the INRA, which also it's an agro-based institute. They are very concerned about the productivity of biomass producer in that new context. So less production, less surplus, less biomass availability. And the other hand, more incentive for biomass transformation to reduce the emission. So it will be a complex equation. So as Amit says, it's hard to predict the future.
Michael, you're coming also from the feedstock supplier. Are you agreeing with Stefan on this observation on the potential of the Green Deal versus the challenges? Michael, you are muted at the moment.
Was the question to whom?
To you, yes. I mean, we had the question about the Green Deal. How UPM looks at the Green Deal potential for increasing the bioeconomy.
Yeah, I think, I mean, of course, we are following it very closely. It's difficult to say right now. We are not coming from agriculture. We don't compete against food feedstock. From the forestry point of view, there are other challenges, of course, how wood is tackled and what kind of quality of wood you can use for biomaterials. But in principle, increasing the area or increasing forestry means also more wood availability. In that sense, it is good. And the Green Deal as such, the overall holistic picture, I think that is very supportive for us. And we think it is a good thing that EU really focus now on this Green Deal when it comes to sustainability. So we see more opportunities than challenges out of it.
Thank you. Anything from Cas or Nelo also on this part?
On the Green Deal?
Yeah.
Oh, as I put up on the slide here, that I believe that with the bio-based industry, we're fully in line to try and realize the objectives of the Green Deal. Increase sustainability, increase recyclability, reducing waste and all this stuff. Yeah, we're all for it and we're working to realize it.
Thank you, Cas. I mean, I don't know if I have any minutes behind or we as panel have any minutes behind 4 o'clock. I think on my clock it is still 2 minutes to go and then we are at 4. So maybe, Cas, you have the honor to end up the discussion if you.
No, but perhaps I can tell something about my experience as being a green producer of silicon carbide, not biological made at all, but as we were a producer, we were very far away from the consumers. There are a lot of steps between our production and the end product. Like say, it's used in motor blocks for cars, for example. And it was very hard to get an extra price for our product, although it was made very green. So I think in achieving the goals, it's easier for people that are producing bio-based chemicals that are relatively near to the end consumers than for people that are producing material that are further steps away from the end consumers. That in reality, I think that 20% of people said ready to pay 20% more for their products. I think that can be the fact as soon as you are very close to the end consumer. That is being aware of the fact that it's made out of green and bio-based material. But if you are not delivering directly to the end consumer, 20% extra is really a lot of money. And I think it would become difficult. That would be my end conclusion from my side.
Thank you, Cas. Yeah, I think we are now at 4 o'clock, so I like to thank all the presenters for their presentations, which were very interesting, but also for their active participation in this question and answers discussion. And I'd like to give back the floor to Luc to summarize the meeting. Thank you all. Bye-bye.
Goodbye. Goodbye.
Okay, thank you, Ed, and thank you, Kees, for moderating this session, and also thanks to the speakers for giving your excellent contributions, both as presentations and also in the discussion that we had. I think we had an interesting 2 days. So I'm trying to summarize a little bit the 3 sessions in a row with a little bit different perspective, starting with the first session looking at more the process heat in industry, more the local industries which were relying on local biomass more and also having fuel technology options already available. The second, looking more into energy intensive industries, particularly the steel and cement industries, which are in fact big industries and would have to rely on a big amount of resources, a big amount of biomass. So they looking into availability is very important for them. And then we had this session, which is more in the chemistry focus, also with the bioproducts and how to market it. Now, we also started with an introduction in the first session, also from the IEA, International Energy Agency, which was actually emphasizing the role of biomass in the whole decarbonization of industry. And the clear message from their side is that they need we all need a large portfolio of solutions. So it's not only biomass can do the job, not only hydrogen or CCS and CCU or electricity. They all have a role to play, and biomass has also a pretty important role to play, which was estimated by IEA at 1/5 of the effort that we have to make for CO2 by 2070. So we had these polls, we had the questions, also central questions where people could provide input. So I also want to thank the audience for providing this input, which also gave, well, together with all the case studies we had and the strategies which were provided in presentations, which really brought forward a number of key points which are interesting. One of the main key points is, of course, the cost difference. We have a big challenge that fossil resources are really low costs, certainly at the moment, and we can't really expect them to go very high in future. So this is really a big challenge, and there needs to be a way to include the external costs of fossil products, of fossil resources like the CO2. There needs to be a value around it, an economic value around it. Otherwise, it's very difficult to get this started. Also, you need to, apart from kind of penalizing or putting a price on that, you can also put a value on what are the positive externalities in terms of biomass. And so in some cases you avoid other impacts, like if you have biogas production or if you can use digestate or things like that. So that can also produce positive things. I mentioned that resources is a key issue also. Resource availability, certainly if you have a big scale processes, you have to look for where are the resources. They are pretty dispersed. How can you guarantee the sustainability of these resources? All very important things to take into account. Let's see, and also from a technical point of view, there's also quality concerns, of course, and well, the lower you go in quality of biomass, the lower the costs. So that's a positive thing. But on the other hand, maybe the conversion costs and technology challenges will be higher. So it's kind of in a balance. Or if you want to have a high quality biomass, then you also have to pay a lot more. This discussion about the premiums is interesting. I hope kind of this CO2 pricing will cover that, but it would be interesting also if consumers are indeed willing to pay a little bit more. Probably the 20% is a little bit high estimate, but maybe there is something. Although, I think that can be. We can expect some help from governments. Also, while there is no CO2 price, I think that this push is certainly needed. And also when you're in early stage of technologies, you need to have demonstrations. You need to have first of a kind installations, and then this is very extremely valuable to support these and give good examples. That was also one of the aims here in this workshop, to show some showcase, to have some showcases that provide some examples of how we can move forward. Okay, so I hope this summarizes a little bit. I will also make, well, based on the presentations, based on input I got from the speakers, and also everything I got in the Q&A and in the Slido, we will produce a summary report from this workshop. This will take a number of weeks to get it on, so be a little bit patient on that, but the presentations themselves and also the recordings of these sessions will be available in the next 1 or 2 days. So we will also inform you about that. So thanks again, everybody, moderators, speakers, and attendants for your for attending this this workshop and for your contributions. And hope to see you also in a future occasion. Thank you.